Okay, so I'm going to go through some things about this worksheet, and I'm going to make up other questions that aren't quite exactly the same, but they are structurally the same. All right, so first of all, question 1 is rotations, is a volume of rotation. And so what you want to do is you want to look at some function, let's say x squared minus 4x, for example. This particular function has zeros, and this one is just a parabola that looks like this, goes through 0 and 4. And let's say I want to do a volume of revolution question on this function between 0 and 4. So you're thinking about this thing here as you're making like disks. You're making circular disks as you go along in the dx width of this as you go along. Okay, so what is the area of a circle? Area is pi r squared of a circle, so you should know that. And so what we're going to do is we're going to integrate from 0 to 4 of pi r squared, but it's dx's. Well, what is r? Well, r is y. So what do we get? X squared minus 4x, square that whole mess, and then dx. And I'm not going to actually do this for you. You can do it yourself, and you can also look at Wolfram Alpha if you like to double check your answers, and that's fine. Now, the harder one though is what happens if I want to revolve it around the other axis. So let's say I want to revolve it around the other axis, and I'm going to sort of push this off so I can continue drawing this guy and show you what it's going to kind of look like. Okay, it's going to be coming out this way, and a particular slice, let's say here, if I slice this thing, it's going to go through both of those humps. So if I look straight down on it, what is that going to look like? It's going to look like an outer radius and an inner radius. So it's going to be like a donut shape. It's going to have like a hole in the middle, right? So this distance, okay, so let me try to make this obvious. If this is the center of the circle, then this distance here is the outer edge of the circle, and then this other thing inside here is the inner circle, okay? And again, this gets duplicated on the opposite side, and hopefully you can visualize that. So if you've got this circle, and then this distance here is the small radius, and let's say this distance here is the big radius, I'm going to call the big one capital R and the small one little r. Some people call it R1 and R2. That's fine. So what is the area of this region here? So the area is going to be pi capital R squared minus pi little r squared, or for simplicity, it's going to be pi times capital R squared minus little r squared. Okay, so that's going to be the area of one of these washer-shaped slices. I think they might call them annuluses too. Whatever, it doesn't actually matter what you call it. What matters is how you calculate it. I can't draw straight lines today. Okay, there we go. Okay, so now our next job is to figure out what exactly is the equation here, and also keep in mind that as you're integrating, you're going to integrate from between these two pink dots, okay, because the shape happens to be under the axis. In the other problem, it didn't matter. We got symmetry above and below the axis. Here we don't get that. So this is just a parabola. What's the vertex of this parabola? So if the x here is 2, you're going to get 4 minus 4 times 2, which is 8. 4 minus 8, you're going to get a negative 4. So this lower limit of integration is going to be negative 4, and it's going to go up to 0. And just the symmetry inherent in the problem goes through this x equals 2. All right, so we're going to have to solve for x, and you may not have done this before. So let me just tell you, you have two options here, both of which are things you've kind of seen before, but maybe you've forgotten or didn't use them in this particular way. One of them is just going to be completing the square. I'm going to say x squared minus 4x plus 4 minus 4. You have to agree I did absolutely nothing there. I did nothing because I did add 4, subtract 4. And now I'm just going to group off that square. And so now that minus 4 is left out in the cold. And then I'm going to add 4 to both sides, you know, and take the square root of both sides is x minus 2. And finally, I'm going to say 2 plus or minus square root of y plus 4 equals x. So those are the two functions you have to worry about, the 2 minus square root of y plus 4 and 2 plus square root of y plus 4. Okay? And the other option you would have is using the quadratic formula, believe it or don't. So I'm going to just for a moment, I'm going to erase this to make it easier to see what's going on. All right. All right, so I'm going to say 0 equals x squared minus 4x minus y. And you're like, how did you do that? Well, I just did it. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the a is equal to 1, and the b is equal to negative 4, and the c is equal to negative y. Okay, so you might say that doesn't look like what I just did, but it is, because what's 4 divided by 2? It's 2. And you bring that 2 inside the radical, so you get a 4 in there. And so you're dividing 16 by 4 and 4y. And you still get the same answer. Math is not broken. So that's fine. You have two different ways to get to this lovely expression that is not as bad as it looks. Now, we're going to integrate from minus 4 to 0. I'm going to just throw that pi right outside. And I'm going to say dy over here. And I'm going to look for big R and little r. And this one, the plus gives me the big R. So big R squared minus little r squared. And I'm going to go ahead and throw this in here. 2 plus square root of 4 plus y. And 2 minus square root of 4 plus y. And I never said it was easy. It's just a complete mess. But that's okay, because on the quiz, all I ask you to do is give me, so you'll have an equivalent mess. I'm going to ask you to calculate this at a given y value, just as a spot check to make sure you set it up right, because I don't want you to have to evaluate that. I don't even want to make you type it into Wolfram Alpha. I just want you to get it that far. And in fact, in the quiz, I tell you don't type in the pi. Just save yourself that hassle. Well, if you do, you'll get it wrong, because I assumed you're not putting the pi in. Okay? And so you just evaluate this at the y value I give you, and you type in that answer. Okay, question 2 looks really horrific. It's not. I'm just going to give you one hint. It's use substitution, because you're going to look at it and say that's impossible, but as soon as I say use substitution, the whole thing will unlock for you. Okay, next I'm going to go into the information we need to do question 3, and actually also question 4. It's called length of a curve, or curve length. And so if you have a curve kind of like that, then let's see, you want to figure out how the length, how long that piece of curve is right there. And I've purposely zoomed in on a very straight piece, because I want you to think about what this looks like. Any piece of curve as you zoom in is going to look like a straight line. So what does that mean? I'm looking for ds, which is the change in the length of the curve. And this little piece down here would be dx, and this little piece would be dy. Sure. So what do we know? We know ds squared has to equal to dx squared plus dy squared, because when you zoom in, any curve that is differentiable is going to look like a line. We're going to make that assumption, right? Okay, fine. So what does that mean? Well, why don't I take the square root of both sides because I can. Then I say dx squared plus dy squared. What does that mean? What is dx squared? It just means this little length. What does dy squared mean? It's this little length, and I square it. Okay, so it's just really what it looks like it is. All right, now this is kind of a mess. So what I'm going to do is I'm going to divide everything by dx. But because I have a square root here, I'm going to actually divide by dx squared. And what would you know? This is like dy over dx squared. Notice I did not write d squared y over dx squared. That would be the second derivative. That's not what I wrote. I wrote dy squared over dx squared, which is just the derivative squared. So, now what I'm going to do is I'm going to multiply both sides by dx and get ds is just this lovely expression. It looks a little simpler now. Okay, and so that's where that all comes from. So, what does this mean? This means the curve length, any curve length I want to calculate it from the beginning of the curve, I guess, which is probably like 0 to however long this curve is. If this curve is 10 in length, then that would be 10. And I'm thinking of S is parameterized by the curve itself. It's just like your mile marker on the road. Okay, the total curve length is going to be the integral from the t start to the time end, which is t end, and that's going to be, I'm very sorry, we're going to do that in the next problem. This is in x's. Okay, so it's going to be 1 plus y prime squared dx. Okay, and so if you wanted to look at that differently, it would be like just plain old ds, which is pathetic because this doesn't tell you anything, right? Obviously, you're going to go from 0 to 10 or whatever. Like if you already knew what the parameterization was on the curve, you wouldn't need to do this. That would be kind of pathetic, right? So that's why we're going through all this rigmarole. Okay, so in question 3, I don't ask you to actually solve it, but I do give you the chore of setting up the integral. And like I've been doing lately in these problems, I ask you to set up the integral and then just evaluate the integrand at a particular point, so as a spot check to make sure you probably have the right integrand. Okay, so that's how that problem plays out. Okay, question 4, I'm going to let you have fun with that, and you need to think about those. You really need to think about those. They're not that easy. And what I do want you to do is I want you to play with them on Wolfram Alpha. Wolfram Alpha allows you to do, you can say parametric plot and then something comma something t equals blah dot dot blah. So you can play with that and get it to plot stuff for you and build your intuition that way. Okay? So one of these integrals in 4a is pretty straightforward, and the other one is less straightforward, but don't worry about it because I'm not going to ask you to evaluate anything horrible, but I do want you to be able to set these up. Now, you do have to know how to deal with parametric plots for a curve length. So I have a parametric plot and I need a curve length. Honestly, I prefer doing it this way because think about it. If you have y is a function of x, you can always just say x of t is just x, right? You can just say x of t is t and then replace that x with a t and whatever that function was. You can always take your y as a function of x and turn it into a parametric equation. So if you can only remember one of these two techniques, remember this one because it's more generic. Okay, so we go back to the same discussion we were having. ds is the square root of dx squared plus dy squared. But now instead of dividing off by dx on both sides, we're just going to divide everything off by dt and see what happens. Okay, and then you get dx squared over dt squared, dy squared over dt squared. And let me tell you, if you do the derivative of x with respect to t, there's a really cool, physicists, they like use this really cool notation. They just put a little dot on top of it. So I like to write this as just x dot squared plus y dot squared because I'm super lazy. So feel free to be lazy with me, and that's fine. But I'm going to just write this a little differently in case you're more comfortable with it. I'm going to write it this way, dx dt squared plus dy dt squared, and I'm going to go ahead and put this dt on the other side. Okay, and again, now it's good to integrate. And again, if we knew s, we wouldn't be doing this in the first place, so that whole thing doesn't matter to us, and this is our formula. Okay, so I think that should be enough to get you on the right track, and that is, I lied to you, this is question 4. Sorry, question 4. Okay, and that's great. I will see you soon.